All right, I actually love this question. Let's draw a picture. So we have an upside down cone. Here it is. It has a height of 7 centimeters and a radius of 2 centimeters. And it's filled to the brim with Kool-Aid. Yum. Got some Kool-Aid going on here. Right. Kool-Aid man. That's embarrassing. I'm going to erase that. Okay. So what's going on is we're going to pour this into a cylindrical cup with a radius of 10 centimeters. And we don't know how tall that cylindrical cup is. We're just looking for how high will this volume from the cone rise in any cylindrical cup with a 10 centimeter radius. So first of all, let's find the volume of the Kool-Aid first off and foremost. So this is going to be 1/3 pi r squared times height. So we get pi times 2 squared times height divided by 3. But we know the height, so I don't know why I just wrote h. I should be writing 7 pi r squared times height divided by 3. Figure out what that's equal to. We'll approximate it. So what we get is pi times 4 times 7. Pi times 4 times 7. We're going to divide that by 3. We get 29.32. Okay, well, how high will that rise in a cylindrical cup with a radius of 10 centimeters? Well, we know that, like, let's actually draw a cylindrical cup. Okay, so here's our base. Okay, here's our height. Okay, gosh, it's really hard to draw on this, so don't judge me more than you already do. Okay, so what this is actually going to represent is the cylindrical Kool-Aid. We're going to take this volume of the Kool-Aid and put it into cylinders. So this is the Kool-Aid height. Kool-Aid cylindrical volume. Okay, so all we have to do is we have to take the volume of the cone, 29.32, and set it equal to the volume of a cylinder, which is just pi r squared times height. And we already know the height. Or sorry, we already know the radius. Pi times radius of 10, 10 squared, times height. Okay, we have to get height by itself. So all we're going to do is we're going to divide by 100 pi. We're going to take 29.32, and we're going to divide it by 100 pi. I'm putting it like this, because this is how you're going to have to type it into a calculator if you type it in all at once. So we do 29.32. We divide it by 100 pi. Okay, that's equal to 0.093. So we get 0.093 centimeters cubed. So it doesn't raise very high at all in this cylindrical cup, but that makes sense because we're pouring it from a 2 centimeter radius cone. It's only 7 centimeters tall, right? So it's a very small radius. We're filling that up. And then we did find the volume of that cone. It's pi times 2 squared times 7 divided by 3, which is pi times 4 times 7 divided by 3, which gave us that 29.32. And then we're pouring that into a cylindrical cup. The cylindrical cup is going to have a volume of pi times r squared times height. It doesn't matter what the height of the cup is. We just want to figure out how tall the amount of Kool-Aid is going to reach. So we then do pi times r squared times h, and we set that equal to our volume of our cone. And because the radius of the cylinder is so big, it's 10 centimeters, this is not going to rise very high at all. We do not have that much volume in our little cone here. So with such a wide base on our cylinder, it's certainly not going to rise very high, only 0.093 centimeters cubed. All right, so let's do your extension, though. Your extension is going to be, what if we triple? Okay, we're going to triple the radius of the cone. See how much higher it rises in the cylinder.